Okay, so we have a differential equation, second order equation with the second derivative, first derivative, and the function itself. And we have that equal to 0. Very important class of equations. We do a trial solution y equals ae to the lambda t, so that y prime equals lambda a e to the lambda t, y double prime equals lambda squared a e to the lambda t. So our equation becomes lambda squared a e to the lambda t plus 5 lambda a e to the lambda t plus 6 a e to the lambda t equals 0. Well, we have the common factor a e to the lambda t. This factor can never be 0 as long as a is not equal to 0, and if a is equal to 0, everything is trivial. So we can divide both sides by a e to the lambda t to get lambda squared plus 5 lambda plus 6 equals 0. Simple quadratic equation can be solved by the quadratic formula or factoring or completing the square, etc. And we get solutions lambda equals -2, -3. Easily factored, easily solved by the quadratic formula. So that we're going to get solutions y1 of t equals a e to the -2 lambda t, -2t, lambda is 2, and y2 of t equals a e to the -3t. These a's would not necessarily be the same. These are independent solutions. Okay, these solutions are linearly independent. Because the determinant of y1, y2, y1 prime, y2 prime, which of course then is equal to what? I'll keep the a in here. A e to the -2t, a e to the -3t, -2 a e to the -2t, -3a e to the -3t. And that equals, first of all, I'm going to factor out the a, and if we understand how matrices work, we're going to get an a squared here, and then that's times the determinant of e to the -2t, e to the -3t, -2 e to the -2t, -3e to the -3t, and that equals what? Well, we have -3 e to the -5t and 2e to the -5t, and that's just going to give us a squared e to the -5t. Okay, let's make sure of that. We have -3 and plus 2, so it'd be -a squared e to the -5t. Okay. And we can say that this is not equal to 0 for any value of t, unless of course a is 0. But if a is 0, again, we have a trivial solution that doesn't give us any information. So e to the -5t is never 0. Conclusion, our two solutions form a set, and I'm not going to write the a here because what I'm saying is true even if I do have an a. Okay, but I'm going to say the set e to the -2t, e to the -3t is linearly independent. Within the space of all functions, of all differentiable functions of t. Okay, and that is a vector space. It satisfies all the properties of a vector space. So, and this is a subspace. It's a linearly independent set within the space. Its span is a subspace. So we'll talk about, well, I'll say that now. So the span of the set e to the -2t, e to the -3t is the set, or let's say the subspace of what I call D, the space of all linearly independent solutions, And it's a subspace consisting of solutions to the differential equation that we started with. So now we want to find solutions. And that would be a specific function y of t such that y of 0 equals 0, y of 1 equals, y of 0 equals 1.